the reason I put this day in here is because I wanted to really emphasize the idea of elimination before we go on to the next section. Elimination is probably the most used method to solve a system of equations. Now, little review again. We keep using the word system of equations. All right? What is a system of equations? Once again, what is it? At least 2 lines. It's 2 or more lines. And what is the solution of a system of equations? What have we talked about every day? Okay, it's where the line crosses. It's a point. So in each of these cases, we're looking for the point. Now, a little bit of a review. Our first one, we have this equation, 7x plus 8y equals 8, 14x plus 2y equals 4. I've shown 2 different ideas here in terms of multiplying by a scalar. In the first one, I'm going to try to eliminate the x's. And so I'm going to key in on these 2 numbers. And John, this kind of hints to what we talked about at the beginning of class. As I look at the 7x and the 14x, I'm going to target one to be a negative 14 and one to be a positive 14 as a target. If I want to make this top one a negative 14, I'm going to multiply it by negative 2. And so here I multiplied by negative 2. So negative 2 times 7 is 14. Negative 2 times 8 is negative 16. And negative 2 times 8 is negative 16. Then I go about and finish solving the problem. Now, I didn't finish it. The whole point of this is understanding, Luke, what is our target scalar? And remember, the scalar is that multiplier. The scalar is the negative 2. Now, this isn't a nice answer. I didn't finish it. I'm not concerned about how the problem works out. I'm just concerned about how we target that scalar. Look at the same problem down here at the bottom. Now I want to target the y's instead. And say, what if I instead tried to drop out the y's? And so here, Justin, I'm going to say, okay, I have an 8y and a 12 and a 2y. Now I'm looking for 8 and negative 8 as my targets. To get a negative 8 out of that 2, my scalar is negative 4. So I multiply each one by negative 4, distribute them all, add them up, and go from there. And the idea that we're looking for today is just really working on identifying what's the scalar that makes it the easiest to solve. That's our goal. Now, I didn't finish these problems, intentionally. It was just a case of trying to understand. Sometimes you have a choice. Maybe Noah decides to drop out the x's. Maybe Zach decides to drop out the y's. Neither is right, neither is wrong. They're both just very different approaches. So, flip it over, and I just have 2 problems today that I want to kind of go through and look as options. The first one says solve it by elimination. So it's being very specific in its choice. We have negative 2x, 5y, and 20, and 3x, and 7y, and 26. Now we need to make some choices. What do you feel would be the smallest number that we could target either for x or for y that would be easy? Talk to me. 6? Okay, so you're thinking of the x's. All right, good job, Luke. So 6. So you're going to target one to be a positive 6 and one to be a negative 6. Which one do you want to be the positive 6? The bottom. So what is your scalar choice? Okay, so multiply by 2. And what about your scalar choice for the top? Well, if you choose negative 3, that'll become positive 6, right? So positive 3. Good catch. Because remember, we want one to be a positive and one to be the opposite. So let's distribute those. Luke, you did a nice job there. 3 times each of those 3. Noah, can you do that for me? Distribute the 3 times each one of these. Positive 15y. Good job. Nice. Well done. All right. Going on from there. Drew, would you be comfortable distributing the 2 to the bottom equation? Good. 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 52. All right. We draw our line underneath. Now we have our target. One's a positive. One's a negative. We look at our y's. That's very convenient. Y equals 8. It goes from a really complicated equation, boom, to y equals 8. All right, let's plug that y equals 8 back in. What do you think? Sam and Ryan, first equation or second equation? Which one do you want to use? Second, okay, so we're going to use the second equation. I'm going to copy it down. Now, something that came up yesterday, I forget if it was in this class or another class, but the idea that you always go back to the original equations when you plug it back in. I had some people trying to plug it into these ones. Always go back to the original. So here we go. 3x minus 7 times 8 equals negative 26. So 3x minus 56 equals negative 26. Add it. 3x equals 30, which leaves us with x equals 10. Because the numbers are so perfect and so even in terms of what they ended up to be, I'm almost absolutely certain it's right. But I still need to go through the process and check it. Ryan said to use equation 2 to solve it. So just check it, Ryan. I must use what equation? The first, okay. So I'm going to recopy down the first equation. There it is. Plug in my values. 10 and 8. So negative 20 plus 40 equals 20. Is that true? It certainly is. So my answer is 10, 8. The idea is we've got to identify the scalars to drop things out and make it easy. Is this more realistic, do you think, in terms of a normal problem? Versus the ones, remember the first day? It was like 5x minus 2y and then 5x plus 2y. You know, it was like exactly opposite already. This is much more realistic in terms of targeting and trying to get to something that's a scalar multiplier. So, all right. Look at number 2. It says solve by any method. Now, what methods do we have in our arsenal? Over there on the left, we have graphing, we have substitution, and we have elimination. Does this lend itself to graphing? No, it's not y equals. So if it was y equals on both things, then Grace, it would be graphing. Does it lend itself to substitution? Is one of the variables by itself on one side of the equation? Okay, that's a key for lending itself to substitution. Now, before we go to substitution, let's look at elimination. Is it set up in standard form? X's and Y's on one side, numbers on the other. This one is, but the top isn't. So what method is the best method probably for this problem? Substitution. So, put a box around the 5y. Remember how we did that? And in the second equation, where you see an x, what do we replace that with? Yeah, a 5y. And there it is. That gives us 10y minus 3y equals 7. Hannah and Brett, can you take me from there? 7y equals 7. Keep going. Y equals 1. Hannah, can you go from there?
Yeah, so then you would go to the second problem and then, yeah, you go back to the first problem and then you would do 5 times 1, which would be 5 times 6.
Good. Yeah, I'd go to that first one just because it's easier. Good call. And then you're going to check it with the second one, right? So 2x minus 3y equals 7. 2 times 5, 3 times 1 is 10 minus 3, 7. Obviously, yes. So your answer is 5, 1. Elimination, very useful. Substitution, also useful. You got to know when to use them. That's the key. When it's standard form, use elimination. When it's y equals or x equals, use substitution. How often do you think you're going to do graphing, honestly? Very little. The benefits of these two methods are the answers can be decimals or fractions What happens when you're graphing? You can't necessarily tell if it's exactly crossing in that spot unless it just happens to be a perfect graph and you're so accurate. If you're that accurate, you might want to think about a degree in architecture and drafting, because those guys have to be right spot on. So, questions? Josh?
What's standard form again?
Standard form is when the x's and y's are on the left and the number without a variable is on the right. Remember, ax plus by equals c? Does that ring a bell? So that was what we called standard form. All right. Here's our assignment down at the bottom. It's the same thing as we did yesterday. It's elimination. But some of the problems on this, you're going to have a choice. When it's x equals something or y equals something, Tara, that's where you jump in and you say, oh, that's substitution. When it's standard form, that's where you're going to jump in and do elimination. Okay? So here's our assignment, and this should not say practice. This is a practice quiz, and it's behind. Take a look back behind there. Flip back one.